Well, hello there, everybody. Welcome to SkyTour livestream for this wonderful 23rd of May, 2023. Let's welcome Daryl to the stream. Hi, Daryl.
Hello, Mark. How you doing? Hello, everybody.
Doing well, thank you. Thank you. Things seem to be cranking along at a reasonable rate. I figured tonight we're going to do another stream to just sort of check out the Supernova. And Michael Hedrick says, yay, 1080p. Yes, Michael, the small mini computer that I use only allows us to go to 720. I'm on the big boy right now. I'm on the main system. And so you have 1080p tonight. I'm glad. All right. Hey, Daniel is here with us. Good morning, sunshine, he says. We have Michael's with us, as I mentioned. Cyclone here was the first one. Nicely done. Nicely done, Cyclone. Judy M is here. RJPX, how you doing? I said hi to you, Michael, but I'll do it again because you're a good guy. Hi, Mike. And then Daniel's with us, as I mentioned. And Daisy and Zoe Amethyst are here. And I have to tell you, we're going to quickly get going over to the Supernova because I'd like to spend some time checking it out. And it's going to be, it won't be a 3 to 5 hour to 20 hour stream like we normally do. Okay. So tonight is just going to be a quick stream to check on the progress of the Supernova. And we can talk about some of the chemistry going on as well. All right. So if you watch the telescope right there, you see it's moving. All right. And you can see the stars zipping by there. All right, so our planetarium system is done. We don't need that. And we have the full frame here, 4 full moons across. There it is. One, well, 3 full moons tall. And I can
see the supernova.
I can see it. It's very, very bright.
Yeah.
I think it outshines the whole galaxy as of tonight for sure. Probably last night too. You know, hey Mazif, how are you? Fantasy, how you doing, brother? Good to see you. All right, so what I'm going to do is I'm going to head to the west with the telescope a little bit to kind of bring that centered a little more. Okay, that was too much because I forgot to take it off the high rate. That's not a problem because I'll get it back. All right, so I'll just do this, see where I am. Yeah, I took off a little bit. So, here we come. There we are, bring it back, and now I'll set my rates to what they should be. I'm excited to see the supernova tonight, guys. This will be interesting.
Oh, yeah.
I really enjoy this supernova. Okay. I will set up our name already so that we don't accidentally save it to a non-sense file. This is Measure 101, M101 Galaxy, and it's a supernova. All right. So, how is everybody doing tonight? I'm going to move this over, and while you're telling me how you all are, I will reposition the telescope to bring this object dead center. And to do that, we'll do our little crosshairs and our target. Let's target this guy. Fantasies got a comment there. I got a lot of requests for tonight. I've picked up at home M92, yep. And the cat eye nebula. Oh, okay. Well, we can do that too.
Remember, we tried the cat's eye a while back. It was still too low.
Yeah, so we got to figure out where it is now.
Hopefully it's up now.
Hey, look who's here. It's Sean Farva. Hey, Farva. That's not his real last name. I know his name, but I just wanted to call him by his avatar name. All right, so let's go down here. just pop a little bit more westward. And we'll get out of this. A little more. We don't have to be centered. As you can see, the stars are nice everywhere. I just like to be centered because it helps set up the target. You know, and it's nice. Okay. So here we are, and we're waiting now for our guide star to commence, and there it is. And once it stabilizes, I will take an image for you. By the way, I decided to stream about 10 minutes ago, and I had an awful lot to do to get it to work. So it was pretty crazy. All right, let's go do a 25-second shot on this, and we're going to pop out here and go into a live stack right away. And while that's happening, I will check out a few other things. Yeah, okay. Okay, there we go. All right, let's do some processing. All right, and color correct. All right, look at that. Okay, now we'll zoom in. By the way, I fixed that problem that we had on the other stream where we had a problem where the screen would go gray, and it will never happen again. We've got that fixed. And what was it, you may ask? It was a different way to connect to the telescope out west. Look at that. That looks really pretty. I'm going to put the enhancement on too to give us a little more. I'm not sure it's as blue as it was. Could be. You know, it could be. Let's do the unsharp mask, sharpen up a bit, get some detail.
It does look pretty white to me.
Yeah, and that would go from blue, it would go to white, then would go to yellow, then to orange as it starts to fade, you know. So. So I do not get it.
What did you not get?
Oh, the Rumble stream didn't start, and I think it was because I stopped.
Oh.
I thought it was supposed to start again, so I don't know where it is. No worries. I will find it. Okay, we'll just wait for some more of these to come in. I mean, look at it. It actually has a tinge of orange to it, doesn't it?
You think?
Yeah, look at it. You see it, right?
No.
All right, let's zoom in a little more.
I noticed your stellarium shows a bunch of those large H2 and nebula regions in the galaxy as NGC objects.
Yep.
And it even identifies the one right next to the supernova.
Yeah.
5462.
That's right, NGC 5462. Just think, when this photo was taken, that star was still there, just happily pumping out radiation. And now it's in the middle of tearing itself apart. All right. That's looking pretty, I'll tell you that.
Yeah.
So when you look at a galaxy, you know, guys, you recognize that there's certain features that in spiral galaxies that seem to be similar to others, and let's draw parallels to our own. In our galaxy, we have spiral arms, like you see here. There's spiral arms, and in our galaxy, spiral arms are the home of the hot young stars because it's in those arms where many of these young hot stars form. The reason has to do with how spiral arms form, and the pressures that create spiral arms also create lots of star birth. And then, when those stars are born, sometimes, again, this galaxy is bathed in hydrogen gas because hydrogen is the most plentiful element in the entire universe and the simplest. And that hydrogen gas can be made to glow red by these hot stars. And that glow is what you see in some of these areas within the galaxy. Okay. For instance, if we just take a look at right here, we have an area that's glowing. We have an area right here that's ionized and red right there. We have one here. There's one here. There's one here. And that may be a compact one or a red star, but it looks close to be looking like it might be an actual H2 region. That is a ionized hydrogen region. And there's many more throughout here.
Yeah. The one just to the upper left of the supernova is an H2 region also. It shows up well in
There.
other images. This one isn't carrying the color very well. It's probably too bright.
Yeah, I mean, I'm doing a 25-second exposure. And keep in mind that our telescope is designed to be a lot faster than other telescopes of its class. So if I knock out some of the noise and the brightness like this, you can see a little more detail in here. Really pretty.
It's almost like it's tinged green now.
Well, this, you mean the H2 region?
Yes.
Yeah, it sort of looks like it is.
I saw on that A-pod from a day or two ago of M101, it's very well defined and it is quite pink. What I find interesting, if you look just to the left and right of the very nucleus of the galaxy, it looks almost like there's an oval around it.
In here, you mean?
Yeah, with a wing on the left and a wing on the right.
Yeah, maybe like this and like that.
Yeah.
Well, this could be
Kind of an eye shape, maybe.
yeah, this might be a barred spiral that has yet to be classified as a barred spiral. It's possible. I mean, astronomers don't know everything, as much as we think we do.
I always find it interesting that spiral arm that the supernova is in. It's really separated from the other arms.
And it's got a little crook in it like that.
It's
See?
got a big crook in it.
Yeah.
And actually, if you look at the one on the top of the galaxy, up at about 1 o'clock, it's got a crook in it too.
Yeah.
Obviously, it's gravitationally interacted with something.
Yeah. You can see how these arms go out here and then they trail off. Something happened to this galaxy.
Yeah.
So if we zoom out a little bit, we can see potential interactors. Okay, we have one here. But then down the bottom here, if we move down to the bottom, I think it's just in the view. There it is. This is an odd-looking galaxy.
Yeah.
In fact, I think it's classified as an irregular. I'm not sure. And that could be an irregular because of interactions with this galaxy.
Yeah.
Yeah. Wow, that's nice. That's 21 frames we have so far, so I'm going to save these right here. Okay, and then save exactly as seen. So what's happening now is up at SkyTourLive.org, which is right below myself here. SkyTourLive.org is our portal to get to all this data and check it out for yourself. You don't need to be a scientist. You don't need to be fancy. You can just go there and download the images we just took moments ago. And I think that's something that makes this whole live stream process something that's enjoyable and makes it able to do some research for, because you can look at other times when we looked at M101, which we have, and literally compare the previous ones to this one, and you'll see that bright dot appear, and it's not in the others. That's called doing a blink comparison. That's the way Clyde Tombaugh found Pluto. I actually saw the blink comparator that he found Pluto with. It's a big, gangly machine with glass plates. So,
I'll post a link to the server for tonight.
thank you. Yeah, I wanted to mention, guys, if you guys are interested, it'd be great if you could go check out our Patreon. Our Patreon is the way that we're going to be able to keep doing this. So you might want to consider joining our Patreon, right? And we've got a number of levels that you can choose from. You don't have to, but it helps us because this is not cheap to bring you. You can only imagine. And if you don't want to join the Patreon, you could actually just do a one-time donation for us if you wanted to. And we are a non-profit organization now, and looking to bring the best in science education in outer space. And our what we say is we bring you the universe live in real time, and that's what this is. This is live in real time. So if that interests you, by all means, I would very much love to see you guys be part of our family in a lot of ways, and maybe even a bigger way. All good. All good. All right, let me make a little adjustment to this right here.
And Bonnie's here too.
Hey, Bonnie. Okay. I'm gonna do a little. Actually, I'm gonna move it this way. I want to bring back some of our screen that was missing. There we go. Not yet. Gotta do a little more. Okay. Almost. All right. Okay. That works for tonight. So if you want to get to our Patreon or anything like that, go to SkyTourLive.org. In the upper left, that takes you to the stream channel on YouTube. In the upper right takes you to the Patreon. And then look at the gifts that you get and the things you get for the different levels you can join in the Patreon. I think Izabela's here too. Yes.
Yes, she is.
Yeah.
mentioned that earlier.
I think I was talking when you did.
Sorry.
No, that's all right. Hang on, I'm gonna get a glass of water. All right.
Okay.
Be right back. Be right back.
Izabela, I hope you're feeling better now. That's good.
Okay, that's good. All right. All set. Okay. I saw some new faces here tonight. It's nice to see. Hello, Wade Williams. How are you? Aloha. Out in Hawaii. I always liked Israel Kamakababoli. He was a amazing musician from Hawaii. Okay. Let's see if we can zoom in now and catch a little more detail. That's looking pretty. I'm actually going to go full screen on this. Get rid of my telescope, pull that over. And then I'm going to knock this out and just go galaxy. Wow. Go even more. This is 120%. Our sensor, its native resolution is here at 100%. Okay, that's a native resolution. So it's a lot more to this side, a lot more to that side, up and down. But because of the nature of this camera, we can go almost to 200%, and it doesn't look all that bad. So it's not bad at all. It's pretty good.
Oh, that reminds me though. Have you focused yet tonight?
I have earlier, but I'm going to do it again because I can see that we'll need it anyway because the temperature out there has been dropping since I opened the building.
Yeah, I see your T-comp is off too.
It is, yeah. It's 26 Celsius in the dome right now. The building. Okay, so what I'll do now is I'll back out. I'll bring back our stack. And dock it up at the bottom. There we go. And let me bring back our telescope. Push that over. Okay. All right. And now move this up. Isn't it beautiful, Daisy and Zoe?
Yeah, I think this is our first night here since the supernova. You see the really bright object at about 8 o'clock in the center of the galaxy, Daisy and Zoe? That's our target.
Actually, I'll show them. Here, let me draw a box around it. This little white, this whitish block right here, this blob. That's a supernova, 20 million light years away, and it's amazing. Claudio Ramos, how are you? How are you? How are things in Chile? Nice to have you with us tonight. He said hi to you too.
Hello. Yes, I said hello to him.
Oh, I didn't hear that. Sorry. Maybe I was getting water when you did.
I typed hello to him.
Yeah, the stream's at 1080p, Izabela. I explained this before, but it merits saying it again. That little tiny computer I have that I use for remotes and on-site streams. That only goes to 720p. A little bit of a surprise. It said it was a 4K output, and it's only doing 720. So I'm going to probably send it back. And although I got it working 100% right now, it's just not at 1080. It only does 720. And go up a level and get the one that can output at a higher quality. And so that one is going to cost another $150. This, believe it or not, that one that I had, which works great right now, actually, cost $279 for something as fast as faster than the machine I'm on right now. But it doesn't have the capability graphically, and it couldn't handle the throughput of the video that we're doing. So that's why it had some issues. I fixed the gray screen crap that was happening. But needless to say, I still can't get above 720. And you got to have 720. I mean, you got to have 1080 minimal. So we will make sure that we are in a much better position to do that higher resolution. That's very important. In the box is the Supernova right there, that beautiful object. Now, I'm gonna say this, and I think I'm not wrong. It was bluer the other night, and now it's sort of whitish.
Yeah.
In this, right? Don't you agree, Daryl?
I do. It looks white to me.
Yeah. No, Claudio, I'm not using OBS. I'm using a different product that allows me to stream to multiple platforms at once. It's called Streamlabs. Rock, Kansas. That's where you are, Daniel? That's pretty cool. No, Ray. The nature of this multi-stream platform is that no one finds out until I actually go live. And I can't help that because it's not like I can set up streams on all these many different platforms and then go have them all go live all at the same time. The software does that. So, that's just something you have to deal with. More than that, it's something I have to deal with. But I will say this, when we did this on Rumble the other night and YouTube, we had about 600 people see it on YouTube the following morning, and 1,200 saw it on Rumble. So Rumble is eclipsing YouTube, and they also have other benefits too that YouTube has. So they're kind of catching up, it seems. All right, let's get out of that box and check this out.
Okay, so you think it's whiter tonight?
I do, but I'm gonna.
Do you think it's brighter than last night? Is it still getting brighter?
Well, see, now here I see a blue tinge now when I drop it down, but that could be an artifact. So what I'm gonna do is I'm gonna get out of this. I'm gonna save it, of course, and then I'm gonna come back in and do a short exposure stack, a very short exposure stack, and see if we can catch the color. First things first.
It may just be saturated.
Yeah, I was thinking that's true. I think it's brighter, which might look like white to the sensor, because the sensor doesn't turn blue if it's hotter, or so. The sensor won't do that. The sensor will look white.
Yeah.
Right. So that's the issue with that. All right, let me get out of this. I saved it. And now what we'll do is go in and do our night vision mode. I'm going to do a focus run. Okay. And so once I do the focus run, then we will do a short stack. Actually, to photograph it out of focus is probably better for color. So why don't I do that first? Because there it is right there. All right. And so let's let's see what happens. Okay, see that right there? You can kind of see the color, right? But let's do a live stack, this 1 second stack. Let's see what that gives us. And it's going to have the previous one in there, so I'll have to get rid of it. Okay, so let's clear that. Get rid of this for now. All right, and let's process. Okay, so there it is. And you can see the color, all right, as you suspected and as I wondered about. It is definitely a saturation issue.
Okay, so
because you can see it's blue.
Yeah, some of that is probably because it's continuing to brighten to the point that.
Yeah, because if you think about it, yeah, because there's the nucleus of the galaxy right there, and this is far outshining the brightness of that right there. That's pretty cool.
Yeah.
Mm-hmm. And where we're looking in the sky, just so you guys can tell, is right here. That's the view from the third camera in the building. There's the telescope aiming up. It's aiming pretty high in the sky, so we have a chance of seeing a really nice view of this tonight. Okay, and that view that we're seeing here, okay, is right here behind me. I've run out of screen real estate, so that's why I did that. All right, so let's come back down and we'll do our focus run after I bring my telescope back into view. There we go. Okay, so we'll get rid of the stack here. So it's definitely blue still, and defocusing a star image is one way to actually get the color. Okay, and that's something that we like to try and do as well. So let's now pump this up. We're going to pump you up, and I'm going to send in our focus just one level, and the stars will all get a little smaller. And then we will do our focus run. There they go. Now, the camera doing the focusing sees the entire frame. It doesn't see the zoomed in portion that we're looking at. Okay. Oops. Okay. Okay, 26 stars. We're gonna scan inward. Well, we will once I catch up here on the keystrokes. I'm waiting for this dialogue to come back.
I don't see your parabola.
I know, it's because I just said that this focus menu, I hit it twice by accident.
Uh-oh.
That's all right. What I can do to reset the speed is I can go out and come back in, and by doing that, all right, what looks like a black screen to you is going to actually help us out tremendously, because now when I come back in, I should be able to get my focus parabola. Righty. See, it picks stars. Notice it says 18, but you only see one, and now you see just, So that's what's happening. So we're going to scan inward now on our focus and reduce the size of the stars until they're the smallest points they can be. And that will represent the bottom of the curve that it's building. And then after that, we'll be able to use that as the perfect focal center. In fact, it'll calculate where the actual bottom of the focal curve is. It's a mathematically derived bottom, because the likelihood that you're going to move the focus a little bit and move it right to the exact focus point is very unlikely. But you can see the curve is already underway here. Okay, it's already heading down, then it's going to go back up. All right, and when it goes back up, the very center of that bottom area, that's going to become our focal point. And you'll notice that now we have 90 stars we're using, and then 83 and 78. Why? Because it's going back out of focus, and the tinier stars are actually going into obscurity again. So that's how that works. It's pretty cool. All right, we have our focus, and we're going to say go to best focus, and this is going to, our telescope is then going to go all the way to one end and all the way back to the other, to rack out and rack in, basically, is what they call it. All right, so right there is technically the best focus that we have. So now we can get rid of this, and I will turn on the temperature compensation, which will adjust the focus based on the temperature changes out there. And there we go. Now we're going to do a short stack. And we're going to just do, I'm thinking maybe 5 seconds. Maybe 5 seconds.
Mark, Izabela has a question of you when you have a moment.
Okay. Go ahead, Izabela. What did she say?
She says, Mark, when is the Contact in the Desert live stream? Will we be able to watch online too?
Absolutely. But it'll only be at 720p because I don't have the time to do that upgrade to get the higher resolution output. But I will. I'm going to get that. All right. So let's...
And when is it?
Oh, I'm sorry. It's going to be on, I think, Saturday night. It's June 2 through 4, and I think I'm on the Saturday. Okay, let's go into the live stack here. And I will definitely... Oh, sorry. I forgot to clear that. I will definitely be giving shout-outs to all of our Patreon friends as well. And regulars. Okay, let's do a little processing on this.
Will you want me for the stream that night?
Absolutely.
Okay.
Yeah.
Remind me.
I will. I'll let you know when I'm going to do it. Okay, so the short stack isn't short enough.
For what?
To accurately get the color of that supernova, we probably would have to go a lot shorter, but that's okay.
Well, the defocusing showed it well.
Yeah. That's really nice. Yeah, I'm going to just see if I can back out a little bit here. We're at the mercy of Starlink out there, so when the Starlink satellites come through, we've got great contact and with the internet, and sometimes you're in between passes and you gotta like wait, which is maddening, but that's what happens, right? It's the technology. What can we say? Without it, we can't stream. That looks nice. I really like the detail in this galaxy. I remember that we looked at this some time ago, and I don't remember it being as good. You know, we weren't looking at it near the horizon or anything like that. It was high. So there's something about the change this telescope has gone through. Something about, I think the collimation, getting that all dialed in, getting the guiding accurate. You know, all this takes a lot of time. You know, and multiple visits 2,500 miles away from here to make it work. You know, and to be honest, I don't enjoy doing it unless, you guys are here. RJPX, yes, that's correct. A nova is not a supernova, as you point out. A nova can be recurring too. If the entire helium layer that bleeds onto a white dwarf from a companion, or hydrogen gas that bleeds onto the white dwarf, doesn't reach the 1.44 solar mass Chandrasekhar limit, then that white dwarf will not explode, but you could get sudden fusion of all that hydrogen on the surface of the dwarf, or fusion of the helium. So that would lead to a massive outburst from the star, and it wouldn't destroy the companion star. All right, because it's only a sudden, rapid fusion of all the fuel on the surface of the white dwarf that's been sitting there. But it gets if it ever gets past 1.44 solar masses, if too much bleeds too fast, okay, then you have a stellar cataclysm, where the white dwarf is what they call totally disrupted. I like to say it exploded. And that's what would happen. It would actually be a total destruction of the white dwarf. Yeah. And white dwarfs come in several flavors. You know, you can have a carbon-oxygen dwarf. You can have a neon and magnesium white dwarf. And those are from different size stars. Okay, a star like the Sun would make a carbon-oxygen dwarf because it can't get past making carbon and oxygen, and the oxygen would be less common than the carbon. But some of these more massive stars that are too low mass to go supernova will create a white dwarf that has the magnesium in it as well, and neon. So it's pretty cool. Hey, Cindy Murphy, I just saw your name go by. Asher's with us. Hey, how you doing? As expected, we are checking in on the supernova, which I think is pretty cool. And we're going to just grab a few more images here, and maybe we'll check out a couple other things nearby.
Would you want to turn your exposure time back up? Will that help grab it?
Grab what?
Galaxy. I mean, you're still on 5-second exposures.
Oh, I know, but look at how good it's coming out for 5 seconds. We can add, you can actually do a, take this curve and add a little bit more punch. You can kind of see what's really there. Okay, I don't like using this curve very much because it It adds a lot of noise, but what it does is it tells you what's really there, hiding in the background, and that's good. Okay, so we've done 72 images here. I'm going to save this too. That's more than enough. Save exactly as seen. Okay, now I guess we could do. I guess we could do. We could do another exposure of this one. Now it's too early to see debris disks and debris clouds around this area. That's not going to be present for. Oh, we probably won't see that for. We won't for a couple of years or more, maybe more. I mean, the Hubble and James Webb will see them. We won't. We will never see them. We won't see them until that cloud expands large enough to be seen by our modest telescopes. But the James Webb will see the destruction pretty quickly.
It makes me wonder if 101 is within the Webb's field of view at this time.
I don't know. It depends where the sun is. And, obviously it's in the night sky, but I don't know if the Webb telescope can traverse that distance.
Right. I've speculated before that I don't really know, but figuring where the Webb is parked.
Yeah.
Out at
a million miles away.
L4 point or whatever, that it probably has kind of a donut-shaped available field at any one time.
Yeah, it's a torus, right?
Yeah.
Elliptical.
So what are we doing?
I'm actually working to try and bring up the planetarium here. All right, and it may go away because sometimes the satellites aren't giving us enough coverage, but maybe it hasn't. Yes, it did. Okay. So anyway, we'll just wait it out.
Michael Hedrick has a question.
Okay.
Could I or Mark please explain why 2023 IXF looks bigger than the center of M101?
Yeah, it's about image saturation, Mike. It's
right.
Just, the sensor takes in light, and if the light's really bright, the object's going to bloat and get bigger on the sensor. That's kind of what we see with this. So that's why it looks bigger and brighter. The fact is, it's still only ever a point of light. Okay, just a very bright point of light. And I mean a point, an absolute point. That's what you see. Okay, so was it the cat's eye?
Yes. I believe it's in Draco, if I remember correctly.
So that might be up high enough for us to see right now. And it looks like it is. Just barely, but that's okay. Let's give it a shot, shall we?
Yep.
Let's first go back and I'll tell it to go first. There it goes. And then let's, oh, we got it 1 second. I already did it. Okay. See, this third camera here helps us to see that the telescope is actually not pointing at the building, whereas the upper camera looks like it is. It actually gives us a better idea of where the telescope's pointing. Okay.
Yeah, Fantasy, it's in the middle of Draco the Dragon. Kind of winds between the Little Dipper and the Big Dipper. Sort of behind the head of the dragon.
Let's go find it. It should be in the view. Waiting for response. Ay, ay, ay. Our Starlink location is considered a low, not resolution, but a low. That might be it right there. I gotta see. I think that's it.
Mark, somebody in chat called Into the Paranormal is asking you a question.
Into the Paranormal. That's supposed to be at mid. Oh, that's today? Oh, great. Yeah, I guess I'm supposed to be on your show. Yeah. I thought it was the 25th. So I'm sorry about that. Okay, if you'd like to reschedule, we can reschedule. Unless you want to... we could actually try to salvage it tonight if you'd rather. Let me know. I actually don't have any contact info for you. I never did. So I wasn't sure what was going to happen there. Yeah, that is it. Look. So let me know into the paranormal what you'd like to do. I'm sorry, that was my mistake. I thought it was tomorrow. Alright, I need to wait and hear from him as well. Alright. Yeah, that's the cat's eye. It looks nice. Thank you for pointing out. There he is. Okay. Actually, this stream was only to do a touch base on the supernova into the paranormal. If you'd like, I can wrap up the stream and come up and hang out with you on your show. You know, I did that now for you. Let me know what you want to do. I'll be happy to do it. Yours was the first obligation, not this. All right. So if you could, let me look and see if you sent me. Okay, we're going to reschedule. Okay. I just checked my email. I didn't have anything in there from you, so I don't know if you even have my contact info. You must, though, huh? Because you found this. All right. Yeah, like I said, I didn't know I was gonna stream. Yeah, they did. Maria set up this interview. So I guess if you want, we can just we can work it out between us to pick a better day, another time. Are you? You're not in the UK. You're in the US, correct? It would actually be kind of cool if you had Skype. We'd bring you into this and we could do this during the stream. That'd be kind of cool. Oregon, okay. All right. So you know Jordan, obviously. I'm gonna guess. This is beautiful. That's a nice little guy. I mean, he has. That's a pretty color. Yeah, I mean, we can reschedule, or if you want to join us on now, we could also reschedule, and as well. I'll give you that time, of course. So we can do something now if you want on right here on the stream. That'd be kind of fun to have you as a guest on the stream, and then I'll be your guest in your show. That's kind of cool. But I guess that won't work out because you want to. It's not just a pre-record, it's a live show, I think, right? So that probably won't work. All right, I'll write Maria and tell her that I did not do this right, and I'll see if I can reschedule. I'm writing her now, just to let her know. That's right, oxygen 3. Hold on, guys. Sorry about this. So next Tuesday at 9:30 Pacific. So that's 12:30 my time. Okay, that's fair. I'll be happy to do that. I'll make a note of it right now. Louis Ta asks a great question. How long does it take a planetary nebula like this to expand? Number one, oh, come on, Daryl. I had a serious issue here. So,
What?
this question...
You want me to answer?
No. You said doodad, and I thought you were just like, you're, because I was taking so long to correct this problem.
No.
Okay. So anyway, the expansion rate can vary depending on the mass of the original star, but we know that after a few thousand years, it's going to expand potentially out to a light year or so, and because it's not moving at the speed of light, right? So it's moving much slower than that. Some of the material is moving out from the star at only supersonic speeds. But over time, the inexorable flow outward just becomes visible. But planetaries are not as well understood as we'd like. So... Oh, James Dugan, did you put up the link for that show?
Yeah, Cindy Murphy did also.
Oh, thank you guys. Hey, at least for my mistake in this, I hope you get something out of this and you get more people who watch your show. I wouldn't agree to do it if it wasn't a good show. Okay, let me make a note of that. And let's first of all...
RRAWWBB. I looked that up a while ago. The last magnitude given by the University of Rochester Astronomy, who they have quite a website, it was estimated at 10.8 tonight.
That's a bright supernova from a galaxy that many tens of millions of light years away.
Oh, yeah. And how long we'll be able to see it? Weeks to months.
Yeah, again, depends on the mass of the original progenitor.
Yeah.
Okay. By the way, Into the Paranormal, if you're still here, what's your name? I don't have any contact info for you. Okay, I'm writing that down.
Jeremy.
Okay, thank you. Nice, thank you so much for that. See, I was supposed to do, it says May 24th, midnight. That's today at midnight, not May 23rd at midnight. So is it possible that you got the day wrong? So it should have been May 23rd at midnight is the date that they should have given me, I think. So I think that will be, but we'll make up for it, Jeremy. All right, so
Cat's
oh no,
eye is only about
what?
1,000 years old.
Yeah. Hey Jeremy, no problem. You're not interrupting me. I mean, from the outside, it appears I blew off your show, and that's not at all what I was doing. So I'm sorry about that. This is all on me. But I do have on the note here May 24th midnight, and I wouldn't have written that down unless it was sent to me that way. I think so. I'll check and make sure, because May 24th midnight is later today. May 23rd midnight already happened, and that's kind of where you're coming from. So either way, I'll just make sure that nobody gets their signals crossed again. Thanks for understanding, brother. That's good of you. All right, let's.
That's like meteor showers.
Exactly.
People always think when they hear a given day for the peak of a meteor shower, they think it's at night when it's actually that morning.
Mm-hmm. That's right. Trust me, I've missed a number of events when I was working in astronomy professionally in the observatory. I was supposed to be doing something at like midnight on a certain date, and I was off by the entire day.
Yeah. That's like when I talked to Bill about meteor showers, or
Yeah.
say it in his chat, that it's like the evening and the night before and the next morning.
Yeah.
Like the evening of the 5th, morning of the 6th.
Yeah.
And Asher, that's a good idea.
Use coordinated universal time.
Yeah.
Yeah. Well, there is an absolute time, right? And that's something that we should use. Greenwich Mean Time, GMT. Yeah. All right.
Well, what are you looking for now? M92?
We could look at M92. We could also see M13.
Yeah, they were both on Fantasy's list.
Yeah. All right. So why don't we do that?
That's the head of the dragon right there on the left side of Stellarium.
Yep.
Elton and his eye. He's looking at Vega.
Well, you keep his grubby little fiery mouthed scales off of Vega. Okay, so we should be right near this. So we'll check it out. I didn't save this because it's not very exciting. Let's go to night vision mode here first. We're at 115%, and good. Look at that. It's right in the field of view. Not bad. I like having a telescope that's aligned. Alright. So let's just head west a little bit. Center it up. Okay. And then we'll wait the obligatory 12 to 14 seconds for our system to lock on a guide star. That's correct, Fantasy. M92 is in the Hercules area. Trust me, Ray. I'm going to image the veil so much that you're not going to be able to stand it. Okay, let's do a... let's say 25 seconds on this. You'll notice that we don't tend to do very long exposures. That's because it's something that this telescope doesn't need. Oh, look, we're going to have a Starlink satellite going through the field. That's cool. All right, let's go live stack it. And let's clear this. Okay. And now let's see M92. And here it comes. Oh yeah, look at that. Let's process. As you can see, I used way too long an exposure at 25 seconds because the core is overblown. Let's see if I can recover some of that by moving this down. And as you'll see, it's not entirely resolved because I blew out the core. That's not bad though. Let's see if we can pull away a little bit. Globular clusters are interesting objects known as halo objects, right? They orbit the galaxy. There's a satellite coming through.
Well, you want to rename your live stack?
Yeah, I haven't saved this, so I'm not. I guess I should though, huh? Because we haven't done M92 this year yet.
Well, Michael Hedrick brought it up.
Okay, thank you, Michael.
Been taking a lot of heat for you tonight, Michael.
What's that?
Nothing. I was joking. James, hopefully we get to go back to it tonight before we finish.
Yeah, we'll take another look at M101 before we're done.
Yeah. This is
Okay.
about prime time for M101. It's
Yeah.
close to the zenith.
Mm-hmm. So let's save this. This is actually pretty good right now. With star clusters, you don't have to stack tons of images. 5 or 6 is more than enough if they're bright. Okay.
When you look at enough globulars, you'll start to see that each one has its own sort of character to it.
That's right. You've mentioned that a few times, I think, with Measure 13, right?
Messier 4
Mm-hmm.
and others. Thank you, Cindy. Been trying to get the bugs out of this new microphone. What's strange is everybody says it sounds great when we're live, and then I go back the next day and listen to the live stream on YouTube, and it sounds awful.
Yeah.
At least I think so.
When I was trying to correct the problem earlier with the show I was supposed to be on, instead of doing the stream, I whacked the camera and it did go off to the side. So I brought it back. Thank you for that note. Okay. While we're here, let's so many good objects. This is
M13 was on his list too, wasn't it?
yeah, I'm going there next. I was just seeing if it was around.
No, it's there's Hercules right there off Keystone. Just actually, M13 is right there in the upper right corner of the stellarium field of view.
I see it up there, yeah.
Says Great Star Cluster.
Well, that's rather presumptuous. Just kidding. Obviously, it is great. Let's go check it out. Okay, we're not yet moving. There we go. Took some time for it to go there. Now, that's M92. You saw how small it was. Now, check out Measure 13 in the same way and consider how much bigger it is. Here we are. Hey, Terry Haig. How are you? Okay. Here we are. We're all lined up. And we should be pretty much centered up. We are at 53%. So we're going to go and center it up and then take an image. There we go.
I
Finally.
can already see the propeller.
I know, that's obvious. It's pretty cool. I like it. Let me see if I can... I've given it commands to move. It just hasn't moved yet. Okay. The propeller Daryl's talking about is right here. It's a little line of stars that go right there. Not a line, but a darkness. Okay, it looks like a inverted Y. So it goes up like this, up there, and then up. So if we were to look at it directly, it's here. Okay, it doesn't want to. I'm not gonna go into that because it doesn't want to respond. All right, so let's go and try to do a exposure then. Oh, great! That was a fast mover. All right, I just need to. That's more like it. Give me that. I'm going to do it 12 seconds. That's not a lot, but for something this bright, we're almost too bright for the core at 1 second. There's an interminable delay with Starlink right now.
They keep flying through your field of view. You'd think it'd be right on top of it.
Yeah. Oh boy. Okay. Well, I'm gonna try and restart this to see if I can get it to get a new session. Maybe that'll help. Maybe it won't. We're gonna find out. Let's try this. All right, that isn't this, so. All right. Now we got 12 seconds on the clock. Let's go. And let's capture something. Whoa, what happened? We got myrtleized.
Always something.
Yeah. Yeah, that's nothing. All right. Okay, see now the core of M13 is visible, which is really nice. And if we live stack that, then that's measure 92. And this next image is going to be measure 13. You watch the difference in size. It's really impressive. Most impressive. But you are not a Jedi yet. So let's do this to show what more there is here, because there's a lot more in this cluster than you can see. See the propeller?
Oh, yeah.
So you see this line of dark area there, and it goes over here, and then it comes down here. It's like a Y with the one line of the Y going up top. That's the artifact that people call the propeller. Pretty interesting. Indeed. Okay. Let's see if we can zoom in a little. Oh, it's very nice. Yeah. See?
Propeller's obvious now.
Yeah, when you pull out the, when you pull this mid-level away from the curve, this yellow line intersects the curve of data. These are the curves of data right here, red, green, and blue. And by color correcting, we actually get the right colors. Get the curves all lined up with each other. The white one is the average of all three. And then when we do this, we're intersecting more data, and so we'll see more and more brightness until it just gets outrageously bright. So basically, we pick a blend. We move back just enough to see most of the stars and leave a little bit of the core. That's pretty cool. And then this is the dark level, so the closer to the curve we get, we start intersecting it. When we get to the top, that's as dark as the background should get. It should never be over here, because then you start pulling away data, see? So just before the peak is just about where we want that dark level. So that's the way that works. And then we can pull this down and modify it. And this is all stuff, let's see, we have a lot of what's called dynamic range. And it allows us to capture many different levels of exposure, which is really cool. All right, look, 13. So what am I gonna do? Pause. Oh, it went 14. Okay. I want to do 13 exposures for measure 13, and I didn't have the right name up here. M13 GC. Okay. All right, so we'll call it measure 14 or 15 now. Just kidding. Okay. All right. So that's going to be up on the server, which you can get to by going to SkyTour Live down below here and scrolling down, and you'll see Take Me to Cool Pictures, and there's instructions on how to get at them. and they're free. Join in and enjoy the fun. If you want really high-end processed photos, well, that's part of the Patreon. You can also get products put on mugs and bed sheets and all kinds of things. We've got like 82 products now, believe it or not, and they are absolutely dynamite. You haven't lived until you've seen the Christmas tree cluster and the Cone Nebula on a blanket for a queen-size bed. It's stunning. Really amazing. And it costs less than a blanket might cost, you know. It's really impressive how they do that. Handles washing as well, very well. Okay.
Izabela, it's, I forget, somewhere between 100 and 200, I think.
What's
How
she
many
asking?
globulars in the Milky Way?
Oh, yeah, Daryl's right. It's I don't know the exact number. Some galaxies have very few. Some galaxies have an astronomically large number of them.
Yeah. Andromeda has a lot more than we do.
Yeah, well, it's got almost 1 trillion stars in it too.
Yeah.
So that's pretty huge.
Mark, I know we've talked about this before, but earlier, when you dimmed down the cluster, the yellow stars really jumped out. What is the story of the yellow stars in the cluster? I know we've talked about this before. Are they just the early ones in the cluster on their way to turning into giants?
Yeah, and we know that some stars in the clusters have become red giants already, and all that means is they've used up the bulk of their hydrogen fuel, and they started up that red giant path for the first time. And stars will go up that path twice in their lifetime. You know, they go up because what happens is when they run out of hydrogen, now gravity wins out and the core begins to contract and gravitationally collapse on itself. But it's not a complete collapse, because as it contracts, it gets hotter and spews out radiation. And what that does is it pushes the outer layer of the star away, and thus it bloats the star into a red giant. That's after losing its hydrogen, right? And then that core continues to contract because gravity's still winning out, and the temperature eventually reaches 100 million Kelvin. And that's another magic threshold, because now the helium leftovers, it's called helium ash, in the core of the star can now be fused further and go into carbon and even nitrogen and oxygen. And so when that happens, that's called the helium flash, when that just suddenly happens. For stars like the Sun, we get a helium flash. For more massive stars, well, that helium onset is more gradual, and they don't have a helium flash. But they do go down what's called the horizontal branch at that time. They actually start going, they stay a little bit brighter, and so they tend to travel backwards on their evolutionary path. They go from red giant to a hotter star again. At least in temperature, with the renewed helium. But that doesn't last that long, maybe 100 million years or so. And then the star, again, it runs out of the helium, and so the core contracts again, pushing the outer layers of the star out even further this time, and it becomes a red supergiant. And thus it starts to travel back and go up into the supergiant branch, possibly, or the red giant branch once again. And that's actually, it's right next to the branch where the star first became a red giant, comes parallel to it, asymptotically, in fact. That's saying it's actually approaching being parallel with that branch, and so it's actually called the asymptotic giant branch, the AGB. And that's the point after which a star will collapse down into a white dwarf or continue on the path to supernova. Depends on their mass. So stellar evolution is extremely complicated, and as one of the things I had to do using Eva Novotny's book called Stellar Atmospheres. Huh. Sorry, I'm probably going to have to kill the stream soon. Eva Novotny's book, Stellar Atmospheres, I had to actually build a star. Computer-wise, we had to build a computer model of the star. And it was very tricky because at every level in the star, you had to account for everything that was happening inside and outside. And so you really, really had to understand. I have that book upstairs. If you want to fall asleep fast, you start reading that book. You know, but it was a really good exercise because my computer printout made a successful star. You know, so I was pleased. All right, what do we got now? Yeah, I know Cosmic Ray really, really wants to image the Veil Nebula, but it's way down here, Ray. We can't do it for you tonight. I'm sorry. Oh, that's funny. But the summer Milky Way is coming up. And all of our summer objects are coming up. We're going to have some fun. Oh, man. Wish I could see Omega Centauri. Because Omega Centauri is literally just past peak. It's only like 6 degrees above the horizon. I could try it. I mean, I don't think we'll see it, but if I get any kind of... I think it's going to be fully behind the building. But you know what I thought of, Daryl? I could actually... If I could open the door of the observatory, I'd be able to see it through the door. I don't know if Daryl's even still with us. Okay, well, we'll assume he fell asleep. All right. I don't think that's going to work. Daryl, can you hear me?
I hear you.
Okay. Because I've been talking to you and you haven't been answering, so I wasn't sure.
Well, you can hear me now. I had to go take care of some business.
No problem. Okay, I'm just going to try this. I know I can't see it, but I'm going to try it.
Omega Centauri.
Yeah, I can't see it, but I'll try it. We're going to be blocked by the building, no doubt. But can I see anything?
Pity you can't fold down the south wall.
I know, right? Yeah, I don't even see any stars. We're very, we're fully behind the building wall. Yeah, that's okay. Oh, look at that. We got a spider building a web over our camera. Did you see that? He's probably wondering, what the heck you looking at me for? Cut it out.
I saw something.
Yeah, there's a spider on there. Okay. I don't think we can see this right now. We can try it. I don't know. The Blue Horsehead? I'll give it a try. It's going to be higher in the sky anyway. make it a partial. I'm not sure. I believe the Blue Horsehead is associated with this pair of stars here. I think so. Did we look at the Blue Horsehead before?
Sounds familiar.
Yeah. Okay. Well, I'm going to...
Isn't it like part of the Ophiuchi complex?
It's in that region, yeah. It's in that region. So what I'm going to do is I am going to just try it. I'm going to try to just image it. And I'll probably get a red glow from the tiny LED on the end of the camera. But
yeah, looks like your number 3 camera. Looks like the roof line will be occulting you a little bit.
yeah, you see that there?
Yeah.
Yeah, right here you can see that. Yeah. Ouch. Okay. All right. So let's plus the internet service is terrible tonight. It's just, it's not responsive. Well, that's all right. It won't come out that good anyway. So, all right. So what we'll do is we're gonna call it for tonight anyway. It's 1:36 a.m. here. But I'm glad that everybody could come out and hang out with us tonight. That was nice. So we'll be back again. I think we had a young moon.
Yes, we do.
Yeah. All right, guys. Well, thank you very much for coming out and hanging out with us. This was supposed to be a quick stream to just check in on Measure 101. But because we're not getting a rapid response here from the system, I don't feel that it's gonna behoove trying to look at 101 again. So we'll check it out on the next night. So.
Oh, you said we could look at the supernova again.
I know, but we can't get the telescope to react. I mean, it takes 40 seconds for it to react. You know, I clicked that 40 seconds ago, and look what's happening. You know.
Yeah.
So that's not good. But that's all right. We'll do it again. I can't make it work faster because that's out of my control. Hey, I got the signal to us, right? So. All right, guys. Well, we'll be back. Thank you for coming and enjoying the supernova and a few other objects tonight. And we will talk to you again. So you guys have a good night. And I'm going to go to bed now.
Good night, everybody. Thank you for coming.
Good night, everybody. We'll see you, tomorrow or... tomorrow or so, yeah. Good night, folks. Remember, keep looking up.